हेलो डियर फ्रेंड्स, वेलकम बैक टू द चैनल। लास्ट वीडियो में हमने डिस्कस किया था कुशनिंग मटेरियल्स के बारे में और इसके फंक्शंस के बारे में। इस वीडियो में हम डिस्कस करेंगे सिलेक्शन, प्रॉपर्टीज़ एंड क्लासिफिकेशन ऑफ कुशनिंग मटेरियल्स। अगर आपने पिछले वीडियो नहीं देखा है तो लिंक डिस्क्रिप्शन बॉक्स में पोस्ट कर दूंगी, प्लीज़ विजिट। एंड अभी हम बात करेंगे सिलेक्शन प्रोसेस ऑफ कुशनिंग मटेरियल्स। सो उसके लिए सबसे पहले तो हमें ये नॉलेज होनी चाहिए अबाउट डेस्टिनेशन, वेदर कंडीशंस लाइक टेम्परेचर, ह्यूमिडिटी एंड रूट ऑफ ट्रांसपोर्टेशन, जहाँ पे अपना प्रोडक्ट डिलीवर होना है। ऑन दैट बेसिस वी कैन सेलेक्ट द कुशनिंग मटेरियल। सो knowledge of destination of the shipment is also necessary to choose the proper cushioning material, as some of them lose their property with the environment changes. Rubber and rubber bonded materials become so rigid or brittle as they exposed to low temperatures. Thus, if it is known that the shipment is destined for reason of extremely low temperatures, then material would be eliminated at the outset. Then delicate items and very susceptible to damage through handling usually requires resilient cushioning materials, and cushioning materials for heavy items must be dense and firm. So here are some factors which should be considered while choosing cushioning materials. First is resistance to the product against damage by shock. Second is weight on wearing surface of the item to be cushioned. When too much weight is concentrated on cushioning material, it compresses to such a degree that it does not absorb the impact or shock energy. Cushion therefore must be sufficient to allow for compression under the weight of article. So weight is also very important. Shape of the surface to be cushioned. शेप कैसा है जो मटेरियल अपने को पैक करना है. Then shock absorbing capacity of the cushioning material, including the effect of moisture on it. Then susceptibility of the material to corrosion due to moisture absorbed by the hygroscopic properties of cushioning material. When the cushioning material has been selected, next step is to determine as how it should be used. Before the correct thickness of cushioning material can be specified for a given application, it is necessary to know certain things about the article, like its dimension, its weight, and its fragility, etc. Based on those factors, we can select cushioning material. Now, properties of cushioning material. The chemical and physical properties of cushioning material are many and may display both desirable and undesirable characteristics. These characteristics vary in importance for different applications. Highly desirable and determined is moisture absorbency, and non-desirable when packaging corroid metal items. So here are some characteristics we can discuss. First one is resilience. Resilience is the ability of the cushioning material to undergo deformation on application of load and ability to recover to its original shape after load removed. Second property is compression set. Compression set is the permanent deformation of the material due to either static load or system to a repeated transit compressions. The cushioning material having high compression set creates more free moving space in the container. Third is the rate of recovery. Time taken by the cushioning material to return to its original shape after compression is known as rate of recovery. Then cushion factor. It can be defined as the ratio of maximum stress to the total energy absorbed per unit volume of the material. Cushioning material having lower cushioning factor requires less volume. Next property is creep. Creep can be defined as gradual deformation of the cushioning taking place over a period of time. Then damping. It is the periodic oscillation of the material before it comes to rest. A resilient cushioning material have been compressed during its recovery should come to its original thickness without any oscillation. Corrosion resistance property. Then hygroscopicity. Hygroscopicity, cushioning material will have less cushioning value or cushioning factor at high moisture content than at lower moisture content. For this reason, when such material are used, they must be protected against long exposure to high humidities by sealed waterproof barriers. Next property is microbiological property. Fungus resistance of some material is low and allow the growth of mold and other fungi. So many materials can be treated to inhibit the fungal growth. However, such treated materials are often very corrosive to metal surfaces and must be isolated from them. Next property is dusting. When there is a disintegration of the bonded fiber structures, materials, and these detached particles, some abrasion happens and some particles remove from packing materials, and this dust can enter into our product or may create damage to the parts. Next property is abrasion characteristics. uh, some materials are abrasive in nature, and they can damage the product. For example, lenses of opticals and instrument, so they may produce scratches to these items. Next is performance at low temperature. So low temperature performance of certain cushioning materials make them suitable for use in high altitude transport, shipment to cold regions, because they remain relatively soft and resilient. Then density. Density is another important property of cushioning material, which limit its uses due to its weight contributing to the tear weight of the package and naturally increase the cost of transport. In other characteristics, it should be considered in choosing the cushioning material are fire resistance, its flammability, and possibility of the material causing health hazard to the person during application. So next one is classification of cushioning materials. Cushioning materials are made of cellulose material or found plastics. There are also special cushioning devices, which are metal springs, fiber straps, and rubber shock mounts. Cushioning materials can be broadly classified into three basic categories as space fillers, resilient cushioning materials, and third one is non-resilient or rigid cushioning materials based on their uses and properties. So first is space fillers. Space fillers are mainly used to fill the voids in packages as done is to prevent reorientation of the items and sometimes to absorb liquid products spilled from the broken unit containers. So space fillers are of six type: granulated materials, fibers and strips in bulk form, paper shavings, creeped cellulose padding, extruded or shredded foam plastics, corrugated fiberboard. So first is granulated materials. Ground cork. Cork is made from outer bark of the holm oak. Holm oak is an evergreen species of Orchis suber that grows mainly in Spain. It is tough, light, and elastic. Because of these properties, it is mainly used as space-filling cushion material. It is corrosive and has poor fungus resistance. It has high dusting characteristics and can contaminate the unprotected items. Sawdust and coat pith. These are cellulosic materials and are cellular in structure and granular in form. They are highly absorbent, corrosive, and have poor resistance. Their dusting characteristics are very high. Kissel gore. This is a fine white cellulose powder containing the remains of alga used as a space filler, particularly around tins of liquid chemicals, as it is non-inflammable and inert. It will readily absorb most liquids. Second is fibers and strip in bulk form. Paddy straw and dry grass. Paddy straw and dry grass Hay are cheap loose cushioning materials used to fill voids. They absorb water and are corrosive in nature. They are abrasive and have high dusting characteristics. Second is wood wool. As per Indian standards IS 1707 and 1960, this material consists of thin, peel-level, narrow shaving of wood. It provides a loose cushioning suitable for nesting individual store or interposing between and around a number of stores where moisture retaining. The wood wool shall be manufactured from coniferous timbers. Only a few names are fir, deodar, cypress, spruce, fir, and blue pine. Wood should be thoroughly sound and dry, practically free from knot and cross grains. The moisture content limit as specified between 8 to 20% at the time of inspection and pH between 4.5 to 8. Third is paper shavings. Paper shavings, known as paper wool, are cheap general purpose cushioning material and provide good protection to lightweight, bulky, and delicate articles, for example, electrical bulb, confectionery, and biscuits. They are used to mitigate shock, to protect the surface from abrasion, and to position the article in a container to prevent reorientation of the object. So, as per Indian standard 4356, the length at least 50% of the cutting shall be 25 cm or above. The amount of cutting less than 12 cm in length shall be less than 5%, and width of the cutting shall be between 3 mm to 10 mm, and limit of moisture content 10%. Next is creeped cellulose bedding. Creep cellulose bedding is used to packaging to perform surface protection. The soft open tissues of cellulose bedding prevent scratching and etching of fine surfaces. It also used to prevent cushioning. Because of its good resilience, lightweight, and low cost, creeped cellulose bedding donates to irregular shape object and prevent items from moving during shipment. Creeped cellulose bedding is generally shipped in two grades: water resistance grade and a water absorbent grade. The water absorbent grade will absorb 12 to 16 times water weight. Water resistant bedding is normally used in case where a non-hygroscopic material is needed. Bedding treated with water resistant resin is designed to absorb less than 3 times its weight in water. Moving to next type of cushioning material, resilient. It is also of 6 types. So first one is bonded fiber material, rubberized hair. The material is manufactured from animal fibers, usually consisting of about 80% horsehair and 20% horsemane, horse tail, cow tail, bonded with rubber latex. It is available in flat sheet and mountings. Next is rubberized core. The material consists of vegetable fibers bonded with latex and is available in sheet of molding in range of densities. It is neutral and less corrosive. In addition to it, it has low content and low water absorption, low dust, and can be treated with fungus resistance chemicals. Next is polyurethane foams. This is formed by polymerization of simultaneous expansion of isocyanate and hydroxyl compound. So there are two general type of flexible polyurethane foams based on polyester and based on polyethylene. Expanded polyethylene. It is a non-intercommunicating cellular material. Expanded polyethylene is flexible and useful cushioning material. It is resistant to common acids, alkalis, and solvents, and slightly attacked by concentrated HNO3. Expanded polystyrene. This material is formed by the polymerization of styrene beads which are subsequently expanded by careful stream heating process. Rubber closed cell expansion rubber. It is non-hygroscopic and has very low water absorption, low corrosive effect, good mold resistance, low density, low dusting temperature range -55 to +45, resistance to acid, and it has good resilience, fair damping, low creep, fair compression set, fair efficiency. Its load characteristic is nearly linear. Next is rubber open cell. It is of two types: sponge rubber, latex foam. Felts also of two types as per Indian standard 1719: pressed felt and needle loom felt. Pressed felt is made by closely felting or interlocking fiber to form a material of even texture and uniform composition without warp or welt. Made by punching one or more layer of animal or vegetable fibers onto a woven base or interply using Haitian. Both belts can give shock protection. Usually, application is to prevent abrasion sensitive surfaces from becoming damaged by rubbing against the container. Spring and shock mount. Springs can be used either under tension or under compression. When used for suspension of an item, they will be under tension, but when used as shock mount, they are under compression. Their natural frequency should be low so that they can isolate the vibrations. Now coming to the third cushioning material, it is rigid or non-resilient cushioning material. It is of three types: molded pulp containers. These type of containers can be defined as article molded from a mixture of water and any type of fibrous material capable of being treated by normal paper making process. The raw material used can broadly be classified into two main classes: moisture in bearing properties of virgin mechanical and chemical wood pulp, either with or without addition of waterproofing, hardening, coloring, or other materials. Second is waste paper pulp, either with or without addition of material as above. Next is polyurethane foam and polyvinyl chloride foam. These both can be formed by a polymerization and simultaneous expansion process. The last one is paper honeycomb structure. A sheet material made of strip of paper bonded to each other such that when the end strips are pulled apart, they form hexagonal cells at right angle to the direction of pull, available in infinite variety of paper and fiber wood material in a range of cell size. Its main advantage is its exceptional lightness. It is widely used for parachute droppings. Here are some examples of cushioning materials. So this is all about cushioning materials. Hope you find this video helpful. Please comment for another such videos with topic of your choice. Thank you. Please do like, share and subscribe the channel.